So we begin the design of a sequential logic using basic latch first. So we're going to implement a basic latch using NOR gate. So for a NOR gate, so suppose we have the input A and B and the output S for a NOR gate. So we have input elements A, B, and output S. So for a NOR gate, so if both input is 0, so it will output a 1. And if input is 0 or 1, or 0 and 1, so the output is 0. This also outputs 0. Then for both inputs are 1, so we have the output 0. So we're actually inverting the output of an OR gate. So to implement basic latch, so we can use a basic set and reset setup or SR latch. So by means of latching, so we can use two NOR gate. Then they are connected cross-coupled. So one of its input is connected to the output of the second NOR gate, and one of the input from the second NOR gate is connected to the output of the first NOR gate. Then we have the input R or reset and the input for S or set. Then we have this state, so let's say this is state QA and this is QB. So we are looking for the input and output components of this circuit. So suppose we have our present state, let's say 0. So we have here Q, then our output QA. So let's say the present state is 0. So we have here 0, and that is inputted to the one of the inputs of the second NOR gate. So let's say for SR gate, so let's say SR, then output QA, so present state is 0. So suppose our input, one of the input for the second NOR gate is 0. So this is 0. Then we have R is equals to 0. So we all know that if for input 1, 0, so the output is 0. Then this is 0. So 0, 0 is 1. But first we analyze this one. So we have here present state 0. So this will be 0. So we have here 0, 0. So the output is 1. So this is 1. So we have here 0, 1. So therefore, our QA is 0. So present state is 0. So we have here our present state 0. So if our present state is 0, then let's say S is still at 0. So this gives us 1. Then this is also 1. So therefore our present state is still 0. So for this input 0, 0. Then next, so we have our present state 0. So that means we have here 0. Then we have here 0. Then now our S is 1. So we have here 0, 1. So that is 0. So 0 being inputted to the first NOR gate. Then suppose our R is 0. So that means we have input 0, 0. Then from this table, so we have 1. So therefore our next state, our present state QA is 1. So therefore we have here a 1. So if our present state is 1, so that means we have here output 1. I'm sorry. So Q is 1. So we have now Q is equals to 1. Okay, so 1. So that means we have here 1. Then let's say input S is 1. So we have 1, 1. So here's the output is 0. Then we have here 0. Then suppose R is 1. So we have here 0, 1. So that means our present state QA is 0. So that means we have here 0. So for this table, so we have here our next state QA, so 0, 0, 1, 0, 0, 0, 1, 0. So that is for present state is equal to 0. So let's try now if our present state is 1. So it's just another color here. If our present state is 1, then that is input to this second NOR gate. Then suppose our input S is 0. So here we have 1, 0. Then its output is 0. Now we have 0 and R is equals to 0. So we have 0, 0. So that means we have state which is 1. So our QA is 1 if our present state is 1. So now we have, okay, so we start at let me draw that in another table. So we have here Q and QA. So present state is 1. So its next state is 1. So we have now here 1. So let's say 1. So input 1. Input for S is 0, so we have output 0. Then we have 0. Input for R is 1, so we have 1, 0. So this is 0. Okay? Then now we have our present state 0. So that is 0 with input s is equals to 1. So we have 1, 1 input. So for 1, 1 input, so we have output 0. So that means we have here 0. Then let's say R is 0. So 0, 0. Then our QA becomes 1. So this is 1. Then now we have our present state Q is equals to 1. So 1. So we have here input 1. Then suppose our S is 1. So we have 1, 1. So that output is 0. So we have here 0. Then our R is 1. So we have input 0, 1. So 0, 1 output is 0. So this is 0. So as you can see, so there's no change for here 0, 1, 0, 0, 1, 0, 0, 1, 0. Then, so we can write here for state QA, if our present state is 0, so we have this output. Then if our present state is 1, so we have this output 1, 0, 1, 0. Then for QB, so let's now derive for state QB. So let me erase this. So we will do the same thing for QB. So let me also erase this one. So same thing for QB. So let's say our present state here is 0. So we have Q. Then we have our QB. So present state is 0. So since this is 0, so we have here 0. Let's say input for R is 0. So 0, 0 gives us 1. Then this is, let's say 1. Then for S is equals to 0, that is 1, 0. Then this gives us 0. Okay? So this is QB is 0. Then our present state now is 0. So we have here 0. So we input here 0. Then for input R is equals to 1. So here we have 1, 0. Then the output is 0. So we have here 0. Then for input S is equals to 0. So suppose we have 0, 0. So our output is 1. So our next state is 1. Now our present state is 1. So we have here 1. Then suppose input for R is 0. So we have input 0 and 1. So this gives us output for QA 0. Then we have here 0. Then input S is 1. So we have 0, 1. So that means our QB is 0. So we have here 0. Now we have our present state 0. So 0. So that will be input to this line. Then R now is 1. So we have 1, 0. So 1, 0 gives us output 0. So this 0 is input to this line. So we have here 0. Then for S is equals to 1, so we have 0, 1. So the next state QB is 0. So therefore, for present state 0, so for QB we have here 0, 0, 1, 0, 0. Okay, so as you can see, there's no change between present state 0. So now let's do if our present state is 1 for this output or this state QB. So if our present state is 1 for QB, so that means we have here input 1. Then for R is equals to 0, so that means we have 0 and 1. That gives us a 0. So this is 0. So 0 input with 0 for S equals to 0. So 0, 0, that gives us 1. So that means we have here our present state Q, next state QB. So 1 gives us next state which is equals to 1. So our present state now is 1. So 1, so this is 1, then R is equals to 1. So 1, 1 gives us QA 0. So this is 0. So S is 0. So 0, 0, that gives us again a 1. So this is 1. So 1 and input R is 0. So 0, 1 is 0 state. So 0. Then S is 1. So 0, 1 gives us next state 0. Then our present state is 0. So that is 0. Input here 0. R is 1. So this gives us 0. Then we have here input 0. And S is equals to 1. So that gives us state QB, output 0. So therefore, if our present state is 1, so there's no change. So still 1, 0, 0. Also for state 0, so the output is 1, 0, 0. So therefore, we can say that at this input, S is equals to 0, R is equals to 0, then there is no change. So therefore, using an SR latch, we generate this table. Okay? So SR input 0, 0, so no change, 0, 1, 0, 1. Then SR input 0, 1, so that gives us QA 0, QB is 1. For input 1, 0, that gives us 1, 0. Then if both inputs are 1, so that gives us 0, 0. So we will further do some modification for the circuit so that we can use the SR or SR latch to our design. Suppose we want to design a counter, so we can able to use an SR latch. So let's start modifying the circuit. So let's add, let's say, another component for this SR latch. So let's suppose we want to add clock input. So we can design a gated SR latch. So we begin by putting some more elements. So I have here an AND gate and another AND gate. Now this is our input R. Then this is our input S. And this is our clock. Then this input, so we're going to connect it with our SR latch. So this will become our R prime for the new value for R, and this is R prime for the new value for S. Now we draw again our SR latch. This is now our Q and Q net. So I will now write the completed table. So I will not perform what we do in our SR latch. So for a gated SR latch, so we have here our clock input, S, input R, and our Q. So for clock equals to 0, then suppose our input for X is 1 or 0. So same thing with R, 0 or 1, or you make it X, that means 1 or 0, so there is no change. So according to the one we generated using our cross-coupled SR latch. So if our clock is 1, then both inputs are 0, still there's no change for Q or state. If our input is, so clock is okay, if our input clock is 1, then we have S equals to 0, R is equals to 1, so we have here S0, so that means we have here 0. So if our clock is equals to 1, so S is equals to 1, that means this is set. So R is 1, 0 means reset. S is equals to 1, that means a set. So 1, 1, so we cannot tell this value, or we can write it as X. Now we can draw the block diagram for our SR latch, or what we call our SR flip-flop. So this is S, R, so this is for the clock, input S, input R, then the next state Q, and its complement. So Q, Q net. So we're going to use this gate for the design of our sequential circuit, and that will be discussed in our next video.